Okay, so today I'm going to be showing you guys how to make some kombucha. So you could see here I have this beer keg that I cut the top off of, and I added on a spigot. And the way you want to brew your kombucha um, is it's very easy. You could just drill a hole. I got some drill bits off temu.com, some carbide drill bits. You drill it in, and then you just use an O-ring. Um, I just cut my own O-rings out of this hunk of leather. I mean, not leather, rubber. So that's the spigot. For heating the water, um, what you want to use is you want to use an electric water heater element. So this is my water heating system. You could see this is the water heating element, and then it just, I run the wires, and it just sits on this little thing, this plug. And this plug gets 240 volts because this is a 240 volt water heater element that puts out around 4 kilowatts. You could see my other video on how to combine two 120 volt lines, and the way you do it is it's over here you combine two 120 lines to get 240, which I plug into. So that takes, I currently filled this up to 5 gallons. This beer keg is like 10 or 15, I think it's like 15 gallons, maybe it's 20. I'm not 100% sure actually, I'll have to remeasure it. But yeah, this is just a first demo, so I just filled it 5 gallons just to make sure everything's good. So the stoichiometry you want to use is, I forget, it's like 20 grams of tea per gallon, and then for every gallon, maybe like 250 or like 500 grams of sugar. So you just weigh it out on a scale. This is my tea, and that's my sugar. I have like 50 pounds of sugar that I bought, so that'll last me a long time. The reason why I want to make kombucha is it's relatively affordable. With these costs, it comes out to be around 60 cents a gallon, and that's cheaper than juice, and it probably has health benefits too, I suppose. But yeah, so the way you want to do this is, obviously, like I said, you boil the tea, and then you add the sugar, and now it's time. You want to get a thermocouple because, they say, you want to measure the temperature when it's boiling and things, but also you want to add the scoby when it's around like 85 degrees Fahrenheit. So we'll let this little thing, I should Kapton tape this on, but it takes a while for this thermocouple to, warm up, but the water is around 85, 86 Fahrenheit, 86 point. All right, now it's stabilizing, so 86, so it should be a good temperature to add the scoby. So I bought the scoby off Amazon, and the thing is, we don't have enough starter tea because I have a pH meter, but it's for laboratory experiments, not for this food stuff. So you want to make sure before adding the scoby, or when you add the scoby, that the pH of the water should be around 4.5. Right now, this water is around neutral because it's just tea and sugar added in, so that's neutral pH. So what we want to do is we want to add some white vinegar, some 5% white vinegar, and then we want to add enough white vinegar to lower this pH to around 4. And then the scobies, I don't really know the concentration of this, but I'm sure when I add that in, that'll drop it down a little more. Maybe 4.25 is a good pH. We start it down because this is not enough starter tea for this 5-gallon batch, and starter tea is expensive. We're not going to be buying that. So you want to do this analytically. So our objective is to ascertain a pH less than 4.5. Okay. So the way I did it is my objective is pH equals 4. We know that pH equals negative log of the concentration of H3O plus ions, which is abbreviated by HA. And we know vinegar is this equation, this acetic acid plus water, because it's a percentage of water in the acid, plus as an equilibrium between hydronium and the conjugate base. So we know that the pH is 4.5. Actually, it comes out, I change it to 4. 4.5, whatever your objective is negative log 10 of x. We solve for x, and we just do simple exponent rules. We equate x as 10 to the negative 4.5. So this is the concentration of hydronium ions. So now we know the concentration of hydronium ions, which is this concentration. We know that to achieve our desired pH of 4. The next question is, what is the concentration of our acetic acid that we need? And then that'll tell us how much acetic acid we should use to add to this vat of water to get our 4.5 pH. So we set up this equation here where M is the initial concentration of acetic acid. And then this is the equilibrium reaction for this weak acid, since it's vinegar. So we set that up and we get M. This is our initial concentrations, unknown. This is a liquid, so it's disregarded. And then the concentration is 0 for our acid and conjugate base because the reaction hasn't taken place. When the reaction reaches equilibrium, we will find that our objective hydronium concentration, we're setting it to be 10 to the negative 4.5. I redid this calculation. We want the pH to be 4, so it's 10 to the minus 4. Because the stoichiometric ratio is the same for these two products, the exponents are 1. So we have our equation for the Ka of the acid. Ka is the concentration of hydronium in this, and the exponents are all 1s because the coefficients here are 1. So we set this equation. So our Ka for acetic acid is, you could Google what that is at a standard temperature, so that's 1.75. I know that we're not at 25C here, but I don't want to redo this math. We're kind of get into the ballpark. And then we substitute our values. Our final concentration of hydronium to achieve our 4 pH is 10 to the minus 4. We know that there's a 1-to-1 ratio of the two things, so that's also 10 to the minus 4. And then our initial concentration M, it will decrease by this amount. So we just have to solve for M in this equation. It tells us M is 0.0067, which means that this is the molarity of vinegar that we need. This is what this is the molarity of vinegar to achieve that concentration. We have to convert this molarity into something more usable. This would be the molarity of this whole solution. Sorry, not this vinegar, but the entire solution in this vat. So we know this vat, 5 gallons is there. That's roughly 19 liters. I have to redo these. So we redo these numbers. 0.067 molarities is moles per liter. So 0.067 equals x moles divided by 19 liters. We solve for x, and that is 0.01273 moles. And we actually can convert that into, what do? We divided this. I forgot how I got the 0.3, but this is, once you get the moles, we know that the molarity of 5% vinegar is 0.83, so we divide the two, and that tells us we need 0.015 liters, which is 15 milliliters. So we need 15 milliliters of distilled vinegar, and that will achieve our pH of 4. So we do have these graduated cylinders, but these are not for food. Those are for research. And we know the dense, so we will do it by weight. So we know that vinegar is roughly the same density of water. So we just tare that. We just have this scale that goes to 15. So we want to get this to 15 grams, and that means this is going to be roughly 15 milliliters. And this is how much we're going to add in to make sure that our pH is okay. You could actually not even have to do all this math if you bought a $4 pH meter, but I don't know what to say. That's probably a better way, but I actually didn't have enough time to do that, so I didn't do that. So that's why I had to waste an hour doing this calculation. So this is 12 point. We're getting close. It doesn't have to be perfect, because I don't really know the pH of the scoby stuff, so I don't want to go overkill, but this should be enough just to you know, just to add some. I actually don't want to put in that much. I want to be a little conservative because I don't want to overdo it. I could always. So I'm not gonna. I'm gonna be a little conservative. So I'm not gonna go that aggressive for a pH of 4. So I'm gonna remove some of this acid. Okay, this should be fine. You know, this should be enough to hopefully get this started. So we're going to pour this amount in here. And then we're going to release our scobies. So now the pH should be good. We want to let that. I did have a stirrer. I don't know where it went, but I guess I'll use this. We want to mix it. You know, we want it to be all dispersed, the vinegar. So now if we measure the pH of this, it would be around 4. We just did the math to figure out how much vinegar we have to add. The math was a little complicated because vinegar is a weak acid, so we have to do a lot of fancy math. But if it was, you know, we used like hydrochloric acid, which we could use. I have that around here. That would make the math easier, but I don't really know how food safe that would be. So now it's time to add the scobies. So let me add that in. I'm going to try to do this one-handed. Hopefully my phone doesn't fall into this. Yeah, my phone might fall into this. Damn it. Alright, let's just do our best. Do the best. Oh, fudge. Bag fell in, but that's okay. So we released our SCOBY. Smells weird, but that's okay. Now it's time to release the second SCOBY. Let's do that. Okay. They do look weird. I think they're like $5 on Amazon for this SCOBY. This guy's big. You know, I kind of wish I had a pH meter because there's a lot of experimental variables, you know, going on where we don't really know the exact pH. But so, I mean, this is, like I said, the water heater thing. We actually don't need that. And I don't want the acid to corrode these electrodes. So I'll have to clean that later on under some water. So then now we just let it sit. Kind of wish I could see in here. Be nice to see where the scobies landed, but I think they're just going to do their thing. So yeah. So the nice thing about the spigot is you could actually, you know, just, you know, you could, you know, fill up a cup or something. That's kind of handy. I have to get a few more beer kegs, but that's basically how you do it. I'll let you know how this this goes, and if this is successful, then, you know, I'll try to do a 20-gallon batch, and I'll do a video on how to do that, and I won't do the math on that. I'll just, because this might cause less views, but that's okay. Regardless, thank you for your time, and if you have any questions, please let me know. We'll have a few other cool videos popping out. I know this video is a little bit unconventional, being, you know, it's more of a food thing, and we're not a food channel, but that's okay. Regardless, have a good day.